start off talking with the testing tree. Now, the testing tree is really the pinnacle of what we're going to be talking about today. This really gives you a really good understanding of how much you should test, what you should test the most of, and how often you should test it, as well as who should test the different tests. All right, so first off, we have unit tests at the bottom. You'll notice that it says unit, and next to unit on the left is CI, and then on the right of unit is devs. Now, generally, you'll have the developers on your team writing unit tests, and you can also have them built into a continuous integration pipeline because they're automated. Now, this is a really important foundation for all of your tests because they're really simple to write and they're also really fast. So you want to have the most of your tests, you want to have those be unit tests. One thing that's also really important is that unit tests are very small, and so individually they're not as important. They could be considered a little bit trivial, but when you put them all together, they are really just valuable to have so that you know that your code works, and you'll know exactly where your code breaks.
I really like those unit tests because, like you mentioned, they're small to start with, but in a whole bunch, when you've got a whole bunch of them, whenever one breaks, you can kind of identify exactly where your app went wrong. And I really like that. What changes came in and broke it?
Yeah.
The unit test's the foundation. What's
next? So next up is the integration tests. Now, these are a little bit more challenging because, honestly, one size doesn't fit all for integration tests. They really can depend on how your application is structured. For instance, if you have APIs, then it could be easy to create integration tests. If you don't have APIs, it could be a little bit harder. So that's why it's above unit tests. Those really kind of depend on how old your application is or how the APIs are structured. Those are also automated, and so you can generally have those run relatively fast, but again, it really depends on the application that you have. It could be that it takes a few hours, so you have to run those tests nightly. So that's why on the left-hand side, you have the nightly builds. So you'll run integration tests nightly. Unit tests, again, they're really small and really fast, so you can run them with continuous integration. Generally, the people that will run or design integration tests are, the devs, as well as working with, testers as well. So they'll usually kind of work together for that. Next up is the acceptance tests, and these are also kind of considered manual tests also because you run them usually not in an automated fashion. You'll usually run them manually, so you'll need dedicated people working through different tests. Sometimes you'll have PMs do them, sometimes you'll have testers. It really kind of depends on the situation. But again, those are slower, so those aren't generally written in an automated fashion. So you won't actually run them in a build automatically.
Unless you somehow have designed and architected your application so that you can extract some of those business rules and tuck them in together and be able to automatically test them. But like you mentioned, that can sometimes be pretty expensive.
Yeah, definitely. And then the last one, well, second to last one, is the user interface, the UI testing. Now, this is also a very manual process. You need to have humans on the left. You have to have them run the tests because, there are some points that a computer can't pick up. You'll have to use those at first. You'll have to use humans for those. And those are, again, those take more time to build. So that's why it's towards the top of the tree. Those are less tests that you should generally have. So you should have way less UI tests than you have unit tests, but those can be run about weekly, and those are all manual as well.
Now, this is an interesting thing because as you climb up the tree, you've got a lot of the effort and how you're going to run them, but we do have this idea of a coded UI test later on that we'll be running. And up that tree, they might fall down a little bit. They might fall more into the integration or acceptance test level once they've been automated, because you don't automate UI tests right at the beginning of an app when the UI is changing really radically.
Yeah.
Otherwise, it's too expensive to maintain.
Yeah, and that's a great point, Steve. One of the really important things about this tree is that, how maintainable these tests are. So unit tests are pretty easy to maintain. If you make a change, then you can just go ahead and change your test while you're doing that, your unit test. But UI tests, if the user interface of your test change, then that makes it really hard for you to, fix your test. It may break really easily. So those are more fragile for sure.
And the last is exploratory testing. Can I take that one?
I know you want to talk about that.
I love that one. Exploratory testing is where you're matching wits with the computer. You're matching wits with the application, and you're attempting to break it not through any scripted tests that have been laid out beforehand that test something in particular, but tests where you're going through the application and trying to understand what it does and potentially break it. Now, we've got some amazing exploratory test tools inside of Visual Studio that are going to be so much fun to show. And one of the things I love about it is you can do an exploratory test and later turn that into a UI test or an acceptance test just at the click of a button. And that, I think, is pretty compelling. That's this testing tree. And there's an interesting history behind the testing tree. This was actually written up on a butcher block paper here in, believe it was in Hungary, in in Budapest, and with a customer. And one of our consultants, Cheryl, sketched this up, and she was walking through it, and it resonated with them, and it resonated with me strongly as well. That tree and how we want to attack it, where the value should go, automated all the way up to these manual exploratory tests. Now, it resonated with me, but I want to come back and talk to you and your experience with testing. This isn't maybe not your testing tree. This is one that came up out of some spontaneous discussions about how testing is important. And granted, there's a little, maybe some arbitrary layers in that tree. But if you come back to what you've experienced, you might have a different testing tree. And that's okay. We need a framework which we can pour some of these ideas into for this MVA. And you should be able to take those ideas, take those concepts, and apply them to whatever testing framework you like to use individually.
Yeah, so I think what's also really important is that, if this is the only takeaway that you get from this session, be sure to, write up your own testing tree, get a bunch of people together and create your own testing tree to see what it looks like. And I think that is really valuable, so you know what your current process looks like and, how much testing you want to actually do.
I find it interesting. Sometimes I'll see a testing tree that looks maybe like this, with the bottom layer being those kind of manual tests, and then a really small trunk maybe where people have done unit tests.
Yep.
I'm a huge fan of unit testing. Want to blow that thing out and get a lot more code coverage to protect from changes. So as a quick look at Visual Studio and how this all ties together, you can see that we've got in Visual Studio 2015 proper, the Visual Studio, you fire up, it's got unit tests, integration tests based off of unit test frameworks, automated UI tests, web performance and load tests are all built there in Visual Studio.
Yep. And then you also have the acceptance and manual tests in Microsoft Test Manager, and you also have it in Team Web Access. In 2015, I believe it might have been 2013 as well, they introduced running manual tests and even running exploratory tests now, which I'm so excited to talk about today, through Team Web Access, which is the web version of TFS. And with exploratory tests, they just introduced within the last couple months an exploratory testing plugin with Chrome. So now you can run your exploratory tests through any Chrome browser.
Does Chrome run on Linux?
I don't know. Maybe.
I think you can now start to run it on all the platforms Chrome runs on, which I think is fantastic.
Yeah.
It's a new leap forward for the way we can do some exploratory tests.
And even on Mac.
And even on Mac. Yep. Excellent. Well, that was the testing tree. So what is continuous testing? It's not a technical term that you might find in industry everywhere, but it's a term that connotes what we're looking for. It's this execution of tests repeatedly against a code base and a deployment environment. And it can be automated unit tests, integration tests, coded UI tests, any type of testing. And the depth of testing often progresses as the environment gets closer to prod. So for instance, we might be running unit tests very quickly as we're doing our continuous integration builds. And as we get closer to production, some of the longer running load tests, which might run for several days or at least several hours, are things that we probably won't run on every deployment to lower levels of the environment. So we might progressively add more tests and more capabilities as we move closer and closer to production. Now, do you run any tests in prod? Absolutely. Your build verification tests, your smoke tests, there's a lot of things you might run in prod, but that also is where a lot of your instrumentation will kick in. So In practice, continuous testing is often one of the most difficult and time-consuming pieces to get right. It's often one of the later things that people plug in to their DevOps environment. And why? Because as your application evolves, and as your infrastructure evolves, and as your configuration evolves, all of these things can break existing tests and cause them to need to be rewritten. So you might need to spend a lot of your time getting these tests just right. So is it worth it? Absolutely. So what are some of the types of testing? And this is by all means not an exhaustive list, but it does bring us from the simplest tests that we might run early to some of the later tests that we'll run late. Unit testing, that testing of a system in isolation. Those things run very quickly on the order of milliseconds, and you'll run these quite often, usually at every build. Integration testing tests components together in a scenario, and sometimes these can be done prior to deployment to an environment, but very often it occurs after a deployment to some type of environment. And these can take seconds to minutes to run generally. Then you have user interface testing or automated UI testing. And here we're going to be driving the tests through the user interface, and these take even longer. Sometimes these can take hours upon hours to run, or at least quite a few minutes. Load and performance testing is the next one, and those, again, should be automated so you can compare piece after piece, release after release, and compare the performance profiles so that you can get continuous improvement. But these take the longest to run. Now, you can hammer a site or hammer your application very aggressively for a short amount of time, but sometimes you just need to run for a fairly substantial amount of time. So these may tend to run for quite a few minutes to hours to sometimes even potentially days. The last types of tests listed here, I've highlighted in a different color, and those are the manual and exploratory tests. This is where you're going to take your human intellect and try to foil or break the application. And these traditionally are very expensive tests, especially in the context of a dev test or a DevOps pipeline, because if you're building things in an automated fashion and you have to pull in an individual user, they can cost a lot of money and take a lot of time. And these are measured on hours to days to potentially even weeks to run some of these tests exhaustively. So what do you do? In your pipeline, we've got the various components in our pipeline, and we're going to start to build them out with things like unit testing right up front, because they're fast and easy to run. And as we go through to things like automated acceptance testing, we're going to be doing those with automated tools that may not take very long to run. And as we get further down, we might start dropping in those humans who can use their intelligence and their will to try to break the application. And that's important too, but often done right at the end before you go to production, if at all. What are the benefits of continuous testing? They're myriad, but here's a few. Quality gates throughout the pipeline, different levels of quality gates throughout the pipeline, and you can choose where you put each quality gate. And if the tests fail, you can go back and automatically fail your entire deployment up to that point. And it comes back, and we get context back to the developers and the operations team that something's missing or something's incorrect, and we can go back and fix that. It gives you increased confidence as well. You just get that really strong understanding and confidence that your code is going to make it to production and at a really high level of quality. Now, I want to add one warning before we leave. Don't tolerate broken tests. If a test breaks and you've got a red dot on your unit test or a test continually breaks, don't ignore that test. At the very least, pull it out of the testing pool. What you don't want is for anybody in your environment to get this attitude of, just ignore that failure, it happens all the time anyway, and the code still runs. Because you'll then miss the triggers that are informing you when real problems exist. So continuous testing, whether it be in those early automated tests that run on unit tests, all the way through to potentially load tests and even some manual tests, are going to be critical for your DevOps pipelines.
we're going to just dive right into test-driven development. We'll give you an overview of what test-driven development is, just from a theoretical standpoint. We'll talk about what the red-green refactor looks like, just the cycle, a nice diagram. And then we'll just go right into demos, these katas that we've been mentioning, these exercises, so that you can actually see what test-driven development looks like. Now, what I would definitely recommend is either you follow along with this example or find some other examples of test-driven development katas yourself, because you really can't understand the pain or the reward of it unless you try it. And I think that's something that I realized when I was working on this myself. So it's definitely different, and you'll be able to understand it way better yourself if you try it out.
I can't agree more. It is one of those things that you cannot learn from watching a video. You can learn the basics, but you have to learn by doing. It's a hands-on keyboard exercise, because it's, and the word kata I think is perfect, because it's that repetitive movement that you do to get your body used to certain movements. It's the same thing. I know people who, as they're learning TDD, will start off with a kata almost every morning. They'll do like a half hour of a kata just to kind of get back into this idea, this building these tests first. Because sometimes it doesn't feel natural. You have to get over that feeling and get into this new mindset. Being test infected is one way to put that. So let's take a look at the first definition that we have. And I'm going to love this definition. It's test-driven development. Clean code that works. A 4-word definition by Ron Jeffries. He's well known for pithy statements. And it is. It doesn't give you much context about it, but it tells you exactly what you're looking for. Clean code, well-architected, well-designed, well-written code that works. Code that is fit to purpose. It's fit to solve the problems you're looking for. And he gets it in 4 words.
Yeah.
I love it.
I think it's great. And I think it also gives you some insight, with the that works part, that it also means that your code is being tested. Otherwise, you don't know if it works.
That's a really good point. So test-driven development. It's integrating testing into your development process, but doing it in an interesting way. Your tests define not what the code is doing, but what the code will do. It's a future look.
Mm-hmm. Yeah, exactly. And so you're not saying, in this case, you're not saying, I have code and I'm going to have my tests do something, or what my tests will do based on my code. It's the opposite. It's saying my tests will say what my code is going to do.
Exactly. And when you do that type of testing, it kind of throws a change into things. So first you write tests, which are code, and then you write the code to make those tests pass. Mm-hmm. And by doing the tests first, you get some interesting behaviors. One of the things that you get is you're putting your thoughts down on how you're going to use the method that you're calling, or the API that you're calling. And so you're thinking through the architecture of how end users, which might just be you later on when you're building your app, are going to be using that function. And so you're putting in the parameters, you're thinking through things. How should this be used before you go in and actually write the code? I like to think of it this way. I generally start by writing some pretty cruddy code when I start, just because I'm getting through an idea, right? My code is not perfect. I like having all of that code in my tests. All the messy code that goes in first, that's in my tests. And then I'll come back and I've thought through it. So the code that I'm writing for production tends to be maybe a little bit cleaner. And then the refactor process, of course, cleans it up a little bit more. Yeah. But here's the gotcha, and it's the last one. I'm going to leave it to you, Sachi.
Yeah, it's so crazy, because the gotcha for this is that you don't write any code that doesn't contribute to a passing test. Now that sounds crazy, right? I think the craziest thing is that you start with tests and then you write code that makes those tests pass, and then you don't want to write additional code that doesn't contribute to a passing test, which is just, yeah, it's just so different.
It is, but it gets to be second nature, and that's the thing. It's so awkward to start, and a few months from now, it'll be second nature to you, and you'll wonder why you did it any other way.
Exactly. It makes it just so much faster. Once you start doing it, you've done it for a long time, then you can understand better how to, create the tests and to create the code, and just to get them to work really well.
Let's talk 2 simple rules. And there's a lot of different ways to think of it,
Mm-hmm.
but 2 simple rules is you only write new code if you have an automated test that has failed. If you've written a test and it's failed, now you can write new code. We're going to come back to this rule because it's not just applicable to greenfield, it's also very applicable when we start talking about legacy development.
Yes.
And the second one is eliminate duplication, right? This is the same principle you have throughout software development. Dry. Don't repeat yourself, right? Don't make a bunch of copies of your code. You find a bug somewhere, you need to refactor one place, it shouldn't force a refactor across a whole lot of different areas.
And that links back to the idea of having clean code too, right?
Yeah.
You want to have code that's, not duplicated at all, and you've looked through it and made sure that it really is the best that you can do.
And you keep mentioning clean code. We keep mentioning that. And I'm going to recommend a book by Uncle Bob Martin. It's Clean Code. It's just titled Clean Code. It's one of those books that it belongs on every developer's desk. You really ought to have that book on your desk, read through it, and understand it. It's especially applicable in object-oriented design. Enforces some of the solid principles. Really good book. Highly recommend it. But a little aside. Let's talk about red-green refactor.
You can go for it.
Awesome. This is the cycle. And red-green refactor, the red comes from a failing unit test in most test runners, pops up a little red ball or a little red checkbox or a little red X. It's kind of like that. And so you write a failing unit test. And why does it fail? We haven't built the code yet. So then you go to green, which means once you have a failing unit test, now you go and you write just enough code to make the test pass. And then you take a look at, do I need to refactor while keeping the test passing? When you're done, you feel comfortable, check in your code, go back to red again, write another unit test. Then you move to green, write a little bit more code. And here's one of the kickers that you're going to see in the katas. As we're writing the code, we're going to be going through and writing very simple code. Even in obvious solutions like the Fibonacci series where we know the end result, we're not going to jump right to the end result. In reality, you might when you're building your code, but we're going to take you through that very simple process because sometimes it's so hard to write code to pass a test that you want to just trim it down and just write any little thing that'll pass. Sometimes that means returning a constant, basically, that is the answer to that red one, because you want to get that first test going and then build upon it. And then the refactoring opportunity is a chance to go in and fix some of those things up. Another look at red-green refactor, something like this. You might write a test, compile, fix the compile errors, run the test, write code, etc. There's sometimes a lot more steps to it, and you'll see this on our first unit test. We'll try to run the unit test, and the code won't even compile. So we have to get the code to compile first before we can run the failing test.
And then here's another look at the red-green refactor diagram again. Another way that you can say it is you could have, write a test that, write a failing unit test, and then you'll make it run. You'll just code just enough so that the unit test passed. Whether that's just literally putting in the method itself, just just an empty method, and then just saying return 0, something like that. And then you want to make it right so it actually is good code, whether it's eliminating duplication, actually naming your variables, things other than X and Y, and things like that. So you're going to make it right, and then you just go through that cycle again to have a failing test, make it run, and then make it right again.
I'm going to go one more. This is the test-driven development by Kent Beck. This is his red-green refactor cycle, and it's just 5 quick steps. Quickly add a test. I love how he puts quickly in here, right? This is not something that should take a long time. Run all the tests, see the new one fail, make a little change. Kent's very specific. This is little changes. These aren't big changes. Then we run all the tests to see them succeed. We refactor then to remove that duplication. It's very similar, but just another way of saying it. And we've given several different ways to say it.
Yeah.
So far.
And what I think is actually really interesting about test-driven development, just after you've been reading these, the steps, is that what the process is, it's just really intentional. You're doing really intentional coding because you're adding a test, you're making sure, you're just creating some dirty code, something that obviously you're going to clean up after it works. And then you just make the test work, and then you go ahead and clean it up. So I think that whole process is intentional. It makes it really consistent if you do that for all of your unit tests, if you can.
Now let's talk a little bit about why TDD works. First, there's a lot of different reasons. There's tons. One is because I think it just makes a team gel better. It communicates better. You've got all of these unit tests that help define what the product does. It gives you confidence in your code. Lots of reasons, but I'm going to come back to 2 core reasons that we come back to again and again and again. Reduces defects. It helps you find and fix bugs earlier. It's one of those things where test later, unit testing later, does the same sort of a thing, but you miss some of the opportunities to think about the problem beforehand and think about all of the edge cases going into it. And I think that's very, very important. It also shortens the feedback loop on your design decisions. Now, we made a conscious decision. Satya and I talked about this. Is the TDD course test-driven development or is it test-driven design? People argue about that. Because when you're writing the test first, you're architecting and you're actually designing what your API and your solution will look like. So that part of it, that short feedback loop, helps you really get an idea of what you're doing and how you're doing it.
Exactly. And that kind of comes back to the intentional coding kind of idea, definitely.
I like that intentional coding. You're making decisions. In fact, that brings us to the next slide, the value prop of TDD itself.
Exactly. One of the main value props of test-driven development is that you have a really predictable process for developing your code and creating tests, because you'll always know that you'll do the red-green refactor just in that same process. And I think the nice part about that is once it's very predictable, then it's a lot faster to do. So like Steve was saying earlier, it may start off as being really awkward at first, but then once you kind of get into the cadence of creating tests and making code that pass them and refactoring that code, then it's just a great way to kind of just have everyone be on the same page and have predictable coding.
You know what? I'm going to come back to that predictable coding and that process, because one of the things that we'll talk about later that Kent Beck mentions, I think is brilliant, is in a software development team, where do you leave your code at the end of the day when you go home? And if you're working on something by yourself, you've got a branch and you're on that branch by yourself, you leave with a breaking test. So you build your test, it fails, you go home. You come back, you know exactly where to start. You start coding right on your application at that point because you know where to start. Now, if you're working with a team, you don't do that because other people might be working on that same source code branch, that same location, and you don't want to have breaking tests checked in. So when you're working with a team, you check in after you have your code working and refactored again so that you have that nice, clean difference of where you might start. And that's kind of that predictable cadence. If Satya and I are working together, I'll know exactly when she's keyed up to, where she is when her code's developed. When she's out of the office, I know she's left me with good, clean, working unit tests all the way up. Improving the long-term maintainability of your code. This for me is a big one, because if you have this underlying suite of good unit test coverage, which is the next benefit, what you get is this confidence in your code. You can make a change, you can refactor your code, you can introduce new things to your code, and you can see all your unit tests pass, and you're confident in rolling that out. Or you may see all of your unit tests fail, and you may decide to pull that feature back out and say, yeah, we thought that was a 3 feature. That's actually an 8 feature if you're using story points or something like that.
Yeah, and then lastly, we'll talk about this tool later that you can use in Visual Studio called code coverage, but really what TDD allows you to do is have really good unit test coverage, which essentially means that most of your code is covered by unit tests, meaning you know that a lot of it is being tested regularly.
Now, I want to come back one last time and take a look at Wikipedia, right? The source of all knowledge, Wikipedia. Seriously, it's a great place to go. So if you take a quick look at the screen, this is where test-driven development is, some definitions of it. And it says there's some insufficient citations and whatnot, but I still think it's very valuable to look at. And it gives a definition that's maybe more complete. Kent Beck, who's credited with developed or rediscovered the technique. So, yeah, you were right. Let's take a look down as we go. One of the things, the cycle is here, running the test, repeating the development style. We're going to talk later about keep it simple, stupid, and you ain't going to need it.
I like that.
We'll start talking about
favorite.
architecture. Exactly. Or the principle, fake it till you make it.
Yep.
But some good best practices here, but I wanted to come down below that. I recommend reading this. But I want to come down to benefits, since we're really talking about benefits. And a 2005 study, that TDD meant writing more unit tests and, in turn, Programmers who wrote more tests tended to be more productive. Here's the gotcha. When people come up with unit tests, they often say, well, management won't let us do it because we're doubling the amount of code we write. Yeah, you might actually be doubling the amount of code you write. In fact, I've seen places that have more lines of code in unit tests than they do in their actual code that they're delivering to production. But I just don't care. If it gives me more features and more tested features, rock on. That's what I'm looking for, is productivity, not the number of lines of code I've written. So you can always refer back to this study. It's one particular one, but it's one that's been borne out in my experience in working with development teams as well. And as we've worked with those, we find that TDD and productivity there really is that nice correlation. Now, it goes on to say that there's some hypothesis that says, it's not clear, there's some inconclusive results, but it's pretty good. If you step back in here, I want to go to one other quote. Programmers using pure TDD on new projects reported they only rarely felt the need to invoke a debugger. Now, I'm a Visual Studio ALM MVP, and I get to sit sometimes and go in advisory councils and talk to the development teams at Microsoft. And I remember the debugger team from Visual Studio coming out with some just amazing things. And one of the other MVPs was asked a question specifically because he was such a fan and a person who applied TDD in everything he did. And he said, and they asked him, how do you like the new debugger things? How does that fit into your development lifecycle? And his response was so clear and pithy. He said, I do TDD, I don't use a debugger. And it was interesting. It caught me a little bit off guard because I do TDD, I still use a debugger at times, and I think it's useful. But when you're writing these tests first, you're validating the correctness of your code right away, very rapidly, in very small chunks. So he didn't need a debugger to find out where that problem was. Years ago, when people were doing unit tests in the 70s and 80s, they called things unit tests, but they weren't automated unit tests. So there was a kind of a weird transition phase as development moved on, and then people started saying automated unit tests. And now today, if you say unit tests, it only means automated unit tests. But just in case you run into that some other place.
Yeah, and I think an important property too about unit tests is to make sure that they're quick, because a lot of times people will think, oh yeah, it's fine if the unit test itself takes 20 minutes to run or something. Yeah. And sometimes it would make people go But what's really important is that when you kick off your unit test, you should be able to know the result of that unit test, what happened, if it passed or failed, by the time you get to your car or out of the office.
Exactly. And that includes all your unit tests, not just that one.
Yes.
You need to know, did they fail, or did they succeed? Let's take a brief look at an anatomy of a unit test.
Yeah, so an anatomy of the unit test, one of the main things that you'll want to kind of take away from that, and you may have also noticed that if, seen demos or, seen other materials outside of this, that usually you'll structure your unit test to be in a range, act, and assert format. And you'll also have, the test method above as well. So if you want to have, use MS test or use NUnit or XUnit, depending on which framework that you use, you'll usually have a property of that method, before. And this example of ours on the slide is in C#. But with going back to the anatomy of a unit test, you'll have arrange, act, assert, and the arrange will actually be the, setting up the variables, just initializing everything, and then acting on it, you'll actually call that method in the unit test, say, hey, I want to do something, and then asserting what the value back from that action is. I think it's going to be 0. Let's actually see what that result is going to be.
I love it. And I think from here, we can go a little bit further and talk what unit tests should be and must be before we hit a demo. They should be automatic. They check their own results. They run quickly. They're repeatable. They can run one again and again and again by multiple people. They're available. They should be with the code. I'm going to bang this drum for just a moment. Make sure that you keep your unit tests in the same source code repository as you have your source code. Why? Because when you roll back your source code to a particular version of the code, you want to have all of those unit tests, which may have evolved over time. And that's where you get those good unit test coverages. You want to be able to have those with your code. There's one that's not in here that I want to mention, and that is you'd better be able to run them in any order They shouldn't have to run in a particular order.
That's great.
Yeah.
I think that's a great thing to add for sure. They should be independent.
Yes, independent of one another. Because if they're running and there's a dependency, it makes them a little bit more difficult to deal with. Now, we're going to be talking about integration tests and often making it different from unit tests, kind of separating the two so we can understand it. Let's get started. So first thing is, where do these things run? And primarily, we're going to be running these in Visual Studio 2015. And that's because they're an automation. We're building automation for these for the most part. They might highlight UI automated tests as well, because they're not always running as integration tests on a unit test framework. So what are integration tests?
Now, integration tests are, we've already mentioned this just a few times, but an integration test validates 2 or more dependent software modules. It validates your application as a group rather than just one single call or method. This is very different from unit tests because unit tests are very constrained by having a single unit that they're testing. But now we're doing it in multiple ways. You know, we're testing different components. We're testing a mail server. We're testing a database call. We're testing file system, anything like that. So it's definitely the main differentiator. Most people think of automated tests as integration tests, but now you know there are integration tests and at least unit tests as well.
And what makes a good integration test is very similar to what makes a good unit test. In fact, let's take a look at the same list and see what we've lined through. So they're automated and repeatable. That we know. We want to be able to run these time and time and time again on our nightly builds if they take a long time. If we can run them quickly, let's build them right there in our build process with continuous integration. They're maintainable. They should run at the push of a button. Maintainable is kind of interesting here. It means that we need to be able to go back and keep them up to date as things change, especially if the API is changing. But they, in general, are very maintainable. We've lined through a few things, however. One of them is they're simple to implement. Why would they be just as simple? I mean, it's just the unit test framework. Why would they be more complicated?
Well, so the challenge with integration tests is that how difficult it is to maintain and to actually implement the integration test depends on where you're working. If you have legacy code and it's all spaghetti code and just scrambled and all messed up, that's going to be really hard for you to create an integration test for. If you have an API already that exists, that's documented, and that's just really easy to work with, that hits, let's say, a database, then that is way easier to implement. So it really depends on where you're at and really how far you've gotten with integration testing as well.
The next piece that we've lined out is that everyone should be able to run it, and not everyone necessarily should. Now, ideally, we'd love everyone to be able to click a button and run these, and maybe that's true in your organization and for your app. But in many cases, integration tests take a dependency on an external entity that may not be available from everyone's machine. For instance, a developer may not have the appropriate API key to call out to some service that makes credit card transactions. Just not something that they're going to give to every developer in the organization. So not necessarily does everybody have the ability to run these. Next thing is they don't always run in memory. What that means is we take this external dependency on things like a database, a mail server, an API that we have to reach out to, which means that we may not be able to run them on the build server themselves. These actually might have to be run after a deployment occurs. So this can be very confusing for people because they may assume that because an integration test is written on the NUnit or XUnit or MS Test unit testing framework, that they should clump them all together and run those unit tests as part of the build. It's the distinction between a unit and an integration test. Very often we have to fully deploy the application before we can run those integration tests. That's an important distinction between those two. Now the last one is runs quickly. Sometimes these can take a while to run.
Yeah.
I've seen these take hours upon hours upon hours to run. So that's one of those things that we should mention. They don't have to, but sometimes they do.
Yep.
If they're based on a UI testing framework where you're clicking through a UI, those can sometimes take an inordinate amount of time. Let's do the most trivial example. If we look at the slides, we've got a client, an API, and a database. And the client talks to the API talks to the database. We're going to test just the API and the database in this case. We could run an integration test by driving the client with a UI framework, but we probably won't need to do that if we don't have to. and we'll just hit the API directly and communicate with the database. That's a trivial and simple example.
Happy path for sure.
Happy path for sure, absolutely. Anything to add, Sachi?
I don't think I do.
Okay.
Integration testing just really depends on where you're working on. So, you know, for our demo, it's a little challenging for us to kind of give this demo that has, you know, everything, because so many different companies use so many different dependencies.
Let's look at the power of integration tests and some of the benefits you have from integration tests as we wrap this module. So we've got 5 here. We're going to lay them out in 5, the key ones. And the first one, I'm going to go back to you with reducing technical debt, because you talked that in unit testing as well.
Yeah, exactly. So very similar to unit tests, you even have most of the same benefits as well. But one of the nice parts of having integration tests is that you can really reduce that technical debt by providing visibility to what your code actually does and how, you know, you can actually make your code better from these integration tests. For instance, if you were a legacy code enterprise and you have all this spaghetti code, by needing to create integration tests, then you can make your code better by having an API.
Absolutely. It also helps you identify coupled code. And coupled code, this is true in unit tests as well, but it gets even more so here, because you're reaching out and saying, all right, we need to talk to our API, our database access layer API, for instance. And we go out to test that API and we realize, oh no, in order to test the database access API, we need access to these 4 other items as well. And so as you start to pull all those together, you can realize if you might be violating some of the key object-oriented design patterns, like, you know, loose coupling and high cohesion, for an example. So those are areas that integration tests can help. The refactoring without fear, I'm going to jump into that one, because refactoring is one of the core jobs you have as a developer. And coming in and refactoring that code, getting it all working appropriately, is something that's critical. And if you go in and refactor and something breaks, you want to know about it right away. But here's the kicker. Unit tests test things in isolation. So sometimes all your unit tests will pass. Without a suite of good integration tests, these might still be passing, but the way they work together might fail. And so it's important to have that suite of integration tests on top of your unit tests.
Yep, I think that's fair. And then lastly, well, second to last, you can validate your business logic as well. This is what is also really helpful for integration tests versus unit tests. Unit tests, you can't really validate business logic very well, but really with integration tests, by having all these live components and, you know, testing their communication, then you're really validating business logic in that way.
And I'm going to steal automated builds from you, because I like them too. I think we both like automated builds. I'll just take this one. You get next one. Automated builds, get those integration tests into your automated builds. But here's the tricky part. A lot of times, it's not just on the build server. You've got to build it, deploy it, and then run those integration tests. And so that part, that cadence, once you get that into your automated build, it means you're getting closer and closer to a DevOps pipeline or a continuous delivery pipeline. And those sorts of things can radically change not just the code and the quality of the code, but the culture of your whole team when you get that really fast feedback. So, Sachi, anything else to cover before we wrap up integration tests?
I think that's it. We're going to go through a demo of integration testing so that you can see an example of what it looks like to test an API through an integration test. And I'm going to drive that demo.
Perfect. Take us along, Sachi.
All right, so we have Visual Studio 2015 open, and this is just a simple C# file for an API test sample that we have. Now, of course, this may be nothing of, you know, it may not look anything like what you have, and this is just really just reaching out to the API, but the idea is generally the same, that you'll have just an API and you're just not going to mock anything. So for instance, we just have an HTTP client to add headers for authorization, and in our tests, we still have the arrange, act, assert, which I think is great because that really provides a level of consistency for your unit and integration tests. But in our test method, we just go ahead and we add headers, we actually hit our API, and then it returns a response. So this is no mocking at all. This is hitting the live site, and the reason that our test failed was because we don't actually have an API here, but
You mean your API URL doesn't go anywhere?
dang it.
No, this is really important here, because if you look at some of the asserts that we have, sometimes we're simply asserting that we get back a 200 if we're calling an API. We might not even be looking at the API itself and is it returning the right thing. We might just be asserting that we can reach out and hit an API. What that'll authenticate is, does it exist? Do our credentials work, etc. So we might have several different tests against the same API for an integration test. Integration tests are kind of crazy. Like you mentioned, here we showed one example, and you kind of apologized. It's not as complex as real world, and it's not. But here's the key problem with integration tests: they are so context dependent that they really depend on what your application looks like. But the key is to take an application, decompose it, start understanding which pieces communicate with each other, connect those pieces up appropriately, and hopefully you'll be able to drive that with something like a unit test framework so that it's pretty snappy. But if not, you may have to drive it with a UI-based interface. Those are much slower, harder to maintain, and more brittle, but can be done.
And one more thing I'd like to add is that I've seen customers generally trying to figure out how to get started with integration testing. And I think one of the techniques that works really well when you're trying to figure out how to integration test is if you actually just whiteboard everything. So I'm going to whiteboard each of my components and figure out how they interact with each other. Then we can just circle, just like we did in our example, we can circle, which things communicate with which. So here's going to be a set of integration tests or a single integration test. So whiteboarding that out.
I think that's a great idea. Let's talk about Visual Studio now and bring it back home to what is in Visual Studio that will help us build these things like load tests and web performance tests. And we clump them together because load tests are generally made up of other kinds of tests. So let's look at this. One is we want to analyze the time that it takes to call a particular web app. So this is before load tests. This is I'm reaching out and I'm making these individual calls. And a web performance test can do this and come back and say, this particular call took 0.369 seconds, for instance. The next one took 6.16 seconds. We can start to get a feel for how long each of these request response things is taking. And we get a lot more details if we want in the log. Things like time to first byte, time to last byte, some of those items as well. We can also put in validation rules here. Some of the validations we can do out of the box are like it must return in less than 5 seconds, or it must return in less than 2 seconds, or time-based ones as well, because it could be we're checking the performance of that site as well.
And if you imagine that these web performance tests are used in load tests, you can tell that it's very valuable to get that information because you'll get the total time for each web performance test. But if you have that at scale, then you'll get the times for all of the tests in a load test scenario.
Exactly right. Load tests.
Load tests. You can use load tests not only to run web performance tests, but you can also have them run unit tests and coded UI tests, any automated tests that you'd like against multiple simulated users. The only exception is coded UI tests can only run one instance at a time on the box, so you may be better suited to do like a web performance test.
I really think so. Yes, it will run a coded UI test, but it ain't much load. So it's just
load of one.
The load of one, right?
But the nice part is that they've recently introduced cloud load testing with Visual Studio Team Services so that you can use cloud load testing and pay for those minutes to do that rather than set up an on-premises system if you don't have that already.
Now, I've got a little bit of a fear about those web performance tests. What if you don't have enough control over that? We've put in some of those validation rules. We've done a lot of stuff. We can do loops. We can do conditionals. We can do all sorts of things. But what if it's not enough? What if there's something special I need to do? Is there any solution for me, Sachi?
Yeah, what you can actually do is, so if you remembered with the coded UI test, what we were able to do was we were able to convert those into actual code, right? So I showed you the UI map, and then I showed you how you can just convert that into code by right-clicking on it. You can do the same thing with web performance tests. So if we go into Visual Studio, and with our web performance test that we just created, we can right-click on it, and we could say Generate Code. And then we can go ahead and call it, And then now we have this really nice format for actual code for our web test. So it'll show us web test requests, and then it shows us the URL, the headers to add, and then it will also show us other information like think time and great information like that. So you can really customize that. And you know, if you need to feel like you have more control with that, Steve, then I think that solves your problem.
It certainly does. I'm not a control freak, but I do like sometimes to really be able to get in there with the code and understand what it's doing and how those requests are being made. And you can just generate it, read through it, really understand it from a code perspective, and then you can throw away the code if you don't need it, or modify it if you want to go that route. Now, load tests are predominantly something that you're going to run from a test rig, potentially, if you're running them on premises, but you could also run them in the cloud. Now, when you're recording them, you're going to use Sachi's approach, which is in Visual Studio to record them and lay them all out, even if you are going to run them in the cloud. But I want to show you a different way. I want to show you the super lightweight way to run these load tests in the cloud. So if you go to my screen, you'll see that I've got my website up in front of me, and I'm going to pop over to Easton. I can load test right from here if I want, but I want to take you the long way. And I'm going to go over to Easton and check on the test tab right here. And from there, I can go to a load test. Now, I'm going to create a load test. Now, when you built your load test, you chose to have your load test running on premises.
Yes.
So it doesn't show up here. If you would have clicked to run it from here, the load would have been from here, and I could have seen it here, which is fine. We're going to go and create a new test. There's two types of tests. You can create, or three types actually. If you create it in Visual Studio and publish it, I can do your style of load test. If I'm going to do it myself, I can do a single URL load test here, or use Apache JMeter, which is another very common, industry common load testing framework. So I'm going to use a single URL test. So I'm going to click that button here, and it's going to say, great, what's the URL of your app? Well, I'm going to go to https://library.nwcadence.com, and we'll call it homepage load from Japan. And the load location, this is where is the location going to be. And, well, I don't have Japan, but I might do Singapore. We'll change that and be appropriate from Singapore.
I think that's really cool because you don't get that kind of functionality if you're doing it on premises.
No,
you
it's
just
really
be like
hard.
Singapore.
Exactly.
Yeah.
So I'm going to run all of my load from Singapore, even though I'm hosted in West US. So I'm expecting to get slightly different results than you might have. I might jack this up to 100 users on the site. I'm going to run it for 1 minute, just like yours, and the delay between consecutive requests will be 1 second. I'm going to distribute this. Maybe I'll do a Chrome 60%, i.e. 40% on this one, just to give it a shot. And let's run that test. Now, this is really easy. A single URL test, regardless of how easy it is to execute, is one of those things that still gives you some value, because we're going to get what is our response time? How long does this thing take? And I think that's pretty potent.
Yeah, even just from, you're just hitting the home page.
Yeah.
So that's one of the most important places for users to hit. If it doesn't load at a reasonable time, then they may not even go to it.
Exactly. And it may not load. If they're coming in from Singapore and it's taking a long time, we may lose some of our customers there, right? All right. If you go out and check again, you can see what's happening. Right now, it's just kind of in this thing. If you look up at the top, it's configuring the agents right here. And that can take some amount of time. It's spinning up and identifying agents that can run. And then it's going to run through this load test once that finishes going. Now, one of the things I'm going to mention while we're in this presentation is the number of, it's in progress, the number of load test minutes you get for free. If you have a VSTS account, you get 20,000 user minutes per month free. That sounds like a lot, but you can burn them up pretty quickly. I've got 200 users, run a test for 10 minutes. That's 2,000 right there, right? So it can go pretty quickly. But you've got a good chunk of minutes that you can use to load test against it. Notice here, it's counting across the top. We're at 15 seconds. Glad I didn't choose longer. Wish I could have chosen 30 seconds, but that's okay.
That's pretty cool. That's nice that it shows that progress bar.
It really is. And it gives you where you're going, and we know we're about halfway there. So one of the things that I like about this is we don't have to spin up like a test rig and all of those other things. Our average response time, 6.3 seconds.
Oops.
It's a long go where that's at 100 users. It's getting down, 5.1 users. And our requests per second is going up. We're at 112 requests per second. And so far, we've had 3,000 some odd requests, 0% have failed. We've had a couple threshold violations, a little bit of maybe slowness that were there. But our average response time continues to decline as maybe that pipe opens and more people are hitting it. That's an example of how to do a very rapid load test right from the cloud, right from Visual Studio Team Services. You get those 20,000 free minutes every month, plus you can run your JMeter tests, that single URL test like I showed you, and you can take any tests that have been recorded in Visual Studio, the way Sachi showed, there as well.
So Steve, do you have any tips and tricks for web performance and load tests?
I do. I've got quite a few, in fact, that I want to get through. The first tip and trick I have is if you're going to run on premises, build out your load infrastructure. Just don't have to do it don't run it off of one machine. Create several different machines, each of which can generate a separate load. What happens when you're running a big load test is your machine may only be able to run 200 to 300 users really well and effectively to load test. So if you need 2,000, spread that out among 10, 15, 20, 30 machines and let the test controller divvy those out so you get a different attack pattern. Another way you can do it is if you want to test from all around the world, you can install them in other places in your organization, like your London office, your Hong Kong office, and you can see the load tests over the WAN as well. Not just that, load test early. It's coming up the pyramid, right? You didn't see it in the pyramid that we wrote, but we put it in because it's really important to get in some of these load tests. I'm going to tell a story, and it's the only time anything like this has ever happened, to me at least. But one of the customers we were working with was running a load test every single night to validate their performance of their application and make sure they didn't do anything crazy. And one night they came in and they ran the load test and their performance dropped substantially, over 70%. So that was a huge drop in performance. It basically killed their app. And they found that it dropped. And the nice thing is they ran it every day. So all they had to do is look at the code delta between when it was last working and when it wasn't. And it was a very small code delta. They could see it in just, they had maybe 100 lines of code they'd added that day. So they could go in to pinpoint where that bug was. Much faster if you're running that every single day. Here's the kicker. It wasn't in their code. It was an update to the ASP.NET framework. This was years ago. The ASP 1-point-something framework had caused this major drop in productivity, the major drop in the performance. It was a bug that had been, bug, maybe a stronger term, but it was a way ASP.NET changed that introduced this massive performance problem. And I guarantee you, they would never have been able to go to Microsoft and say, we think, they wouldn't have known to go to Microsoft. But they wouldn't have been able to go and say, you found this, you have a problem here. Because if they would have run it only once every 2 or 3 months, they would have had such a massive amount of code, they would not have known where to even start looking. And that, to me, cemented the importance of running performance tests as part of those nightly builds, just a beautiful cadence. They don't have to be burn-in builds that run for 30 hours, but give enough load that you can determine if you've had major performance problems. So that's why I'm a big fan. Get those things in your, a la Sachi, that continuous delivery pipeline, right? And it maybe not run every deployment, but it certainly should run every night or at least every weekend, just so you understand the performance implications of the code you're making.
I think that's great. I think that's a great story because I think that really tells you that, by running load tests very often, and if you could even do it every day, that gives you really good historical content so you can figure out the deltas between your code changes or something else like a new version of the framework being released. I think that's awesome.
It is. It's fast feedback, right? Which brings us back to our power of web performance and load tests. It's that time to feedback. Again, beat that agile and lean drum. If we get the feedback quickly, we can do things like understand where we can make improvements. And I think that's all I need to go with that one.
And another thing that you can also find with web performance and load tests is you can probably find this in other tests more or less, but the unique part about web performance and load tests is that you can really find those performance bottlenecks that you can't really find as well in other tests. So I think that's something that those tests do really well, and that's a really important part of your application as well.
I agree. And there's even a couple other types of tests when you create a new test, not the web performance test, but there's other tests in Visual Studio, which we won't be demonstrating, that also help you find performance bottlenecks. For instance, you can run part of your application, and it'll actually return back what was executed against SQL Server and how long SQL Server took to respond back, and those types of things. So you can get really good performance bottleneck information right out of Visual Studio. One I like gives you the hot path. It shows you the slow part of your application.
Oh, yes.
Where should you do your improvements? Again, out of scope for this one right now, but I think it's a really important part that you can use as you're getting more and more and more of an understanding of what's available inside of Visual Studio for all these kinds of tests. You can test under realistic conditions. That's another one that I like. And you know, you get your app out there and you can run this against it, this load test against your test environment, so you can really start to understand and get an idea of what it feels like, especially when we can load test from Singapore.
Yeah,
necessary, right?
exactly. And I think that's an interesting idea too, because, you know, if you're a startup, then you want to make sure that, you know, if you deploy your app, it will actually perform, because you really can't measure that any other way unless it's in production already, and then it crashes and burns if you haven't load tested it before.
I love this integration with Azure too. I've got to plug this because with Azure, you can throw it up, and we talked about how easy Easton scales out, or the knowledge library scales out to do more users. But one thing we haven't done is scale it over to Singapore. We haven't put it in Asia. If we did, then we'd put a traffic manager on top of it, and then the load test would show dramatic improvements.
Yep.
So we could use that to validate, is it worth putting the application in another data center as well?
Yeah.
And give it more failover as well. So let's take a look at improving scalability is the next one. In improving scalability, what we mean is that when you're testing your application and loading, pushing it, you get an idea of where the bottlenecks, where the weaknesses, where the failure points are, and we can come back and use that to get feedback, fast feedback, to come back and give us better and better scalability, make our app more scalable. And we do that by load testing early and often.
And similarly, improving the deployment quality. So if you have multiple deployments of your website, so if it's across to Singapore or something like that, then you'll be able to use these load tests and web performance tests to really have a better quality deployment, which is kind of the end goal, right?
Absolutely. So web performance tests, load tests, we're getting way up that triangle at this point, but something that you should include in your automated delivery pipeline so that you can get higher quality code more reliably each and every time. Up till now, we've really focused on making the tests run in an automated fashion, but it's time to step back and look at manual tests. So let's see where those fit in the grand scheme of things. They fit over on the other tools, manual acceptance tests, under Microsoft Test Manager and Team Web Access. It's a little different location.
Yeah, and one of the interesting parts about that is it's a little bit less code-based, more or less. You know, with unit tests and integration tests, you're writing some code, you're a dev, and you're pretty into the testing while you're coding, or vice versa. So this manual test is a little bit less like that, just because you're doing a lot of, you know, clicks around the UI or the actual application itself.
Fair enough. Let's define a manual acceptance test. It's an acceptance test. This is a pretty simple definition. It validates if requirements or specifications are met. Well, duh, wasn't that what any test does? But here's the key thing on this. I want you to remember that testing pyramid. And in there, we've got these ideas of this acceptance test where we're looking to see, did we meet the business need? Now, when we were talking about unit testing, we talked about TDD, test-driven development. We write a unit test, then we write the code to implement the unit test. There's something called ATDD, which is acceptance test-driven development, which takes it up a little notch. And what we do in acceptance test-driven development is you write potentially a manual test, although with things like Cucumber and the Gherkin language, you can write other things, but you write this manual acceptance test, and then you build an architecture and code to support that manual test. So you're building to the business desired outcome. So it kind of takes it up a level rather than the technical that you do in TDD. So an acceptance test is one of those things that really gets us in and helps us get a good application out the door by acting on behalf of our end user and figuring out, did we meet the business requirements? Did we meet their needs? Mm-hmm. So what makes a good acceptance test?
Well, I can start off with that. One of the things that makes a good acceptance test is that it's simple to implement. Now, that's really important because you're going to have probably a lot of these tests, and you really want to make sure that, you know, people can run it if they want, you know, other people, like other testers, can run these tests. You also want to make sure that they're always available and visible, you know, putting them in a test plan, in appropriate test suites, which we'll talk about in a little bit, but having them organized so that you can find them easily and run them whenever you need to.
Yeah, that's a really interesting thing, because when we talk about anybody can run them, mm-hmm. Anybody can't necessarily run them just on their machine. So like an integration test, we lined it out. We're going to change the meaning a little bit. Anyone should be able to run them, provided they have access to that test environment. So we're changing the definition here a little bit, because we want people to recognize that they should be executed by anyone, potentially end users, potentially anyone who has access to that test environment, or production environment for that matter.
Mm-hmm. And the ones we crossed out were things like automated tests, because obviously these are not automated at all, but we did keep the repeatable because you do want to have them generally repeatable. You can also make them consistent with other tests by having things like shared steps and shared parameters, or, you know, having just a consistent process to create these tests. They're also a little bit harder to maintain because, you know, the requirements are always changing for your application, so they're more fragile than unit tests, for sure.
Definitely, for sure. Now, luckily, some of the cool things you get with coded UI tests in Visual Studio help make them more maintainable, but still, there's a pretty heavy load on keeping them up to date with your UI as you evolve those behaviors. They should not necessarily run quickly, and they don't necessarily run at the push of a button. They might run at the push of 400 clicks and a bunch of keystrokes, but they're manual tests, and so they require that infrastructure to run. Now, let's do a quick look through work item traceability and flow, and I'm going to take you into this slide. Now, this is in TFS, and I want to just put this in context. We might start with a storyboard. You know, a picture says 1,000 words. That's a feature in Visual Studio 2015, the suite that works in PowerPoint. That we might reach out and get feedback from the feedback client mm-hmm. in Microsoft as well, in Visual Studio, the suite of tools. And that's free. Anybody can get access to the feedback client. Now, we're going to create backlog items or requirements based off of those. Those requirements, and here comes the kicker, come into test suites. So we might have a requirement that says, we want, I don't know, as a bank user, I want to withdraw and deposit money in or transfer money in my account so that I can, you know, have enough money to buy something. I don't know, whatever that requirement is. That may spawn a test suite within a whole bunch of different tests underneath it.
Yeah, and a test suite is a really nice way to organize your code. So you can either have them just, you know, organized through a static folder, or you could have them from a query. So you organize those test cases from, you know, a query like I'm looking for all tags or all states. But another way to do it is linking them to requirements, exactly. So you can say, I want all of these test cases to test this requirement. So when you're looking at your requirement, you'll validate, oh, hey, all these test cases were validating our requirement.
And there's even some good reports that pop out of that I think are interesting. Like you say, for each requirement I have, how many tests are built against it, how many are passing, how many are failing, how many haven't been run. Mm-hmm. So that's some pretty neat thing. Now those test suites, they're part of a test plan. So we may have a test plan that's broken down into multiple suites, and those suites contain multiple test cases. Now we're going to keep following this through. Those backlog items are now decomposed by developers into tasks. There's a couple key points here. We're talking testing, we're talking quality. I think it's very important for teams to realize that you don't just write a bunch of test cases after the developers have shipped you code. Because if you do that, you're missing out on the opportunity to tie your test cases to the requirements and the business valued look. If you wait until the developers give you something, you're testing the technical interpretation of the business requirements. You want to be testing the business interpretation of the requirements, and that lets you figure that out. So while as a tester, you're breaking down your test cases, the developers are breaking down their technical tasks, which they will then churn into code. That code is potentially done a code review, and it turns into an automated build. That automated build then is something that all ties together and we can report on. Those automated builds go right back to test plans, because here's the interesting thing. When you're running a test plan, it's testing it against a particular build. And now we can start attributing bugs to particular build, attributing bugs to particular efforts in our development process. A lot of very cool metrics come out of that. I think this is just incredibly powerful. And then the test cases themselves link to automated tests.
Yeah, you can link your automated test. So let's say you have a coded UI test and you want to link that to your test case, your manual test, to say, hey, this coded UI test relates to this test case. You know, this is an automated version of it. Then you'll just have that link inside of that test case so that you can view that coded UI test. You can even click on it and it opens it up in like Visual Studio.
It's wonderful because you've got the kind of end run. Now, we're not talking about automated tests till later, but we'll get there shortly. The last thing on the slide I'm going to throw out here is really just the connection with operations. We file operational issues with tools and operations, etc. But this work item, this traceability and flow, is so critical to a good software development team. And this is enabled by a product called Visual Studio Team Services, which lives off in the cloud, or Team Foundation Server, which lives on premises with you. It's the kind of the back end to Visual Studio to really give it some of the oomph and the power that we need.
We're going to talk about some tips and tricks about coded UI tests, and then we're going to talk about the benefits of coded UI. Now, I've done some coded UI testing with different clients, and sometimes it's had to resort to pixel-based testing. Now, the first tip that I would just like to point out is if coded UI tests, for some reason, if it's through Citrix receiver or if it's just through something else that it doesn't pick up the controls and you have to resort to pixel-based testing, I probably wouldn't recommend doing that with coded UI, only because it's a very fragile style of testing. Because let's say if it's a button, if it moves 5 pixels over, then it's going to break your test, and that makes it very, very fragile. So I would recommend using coded UI in a way that you can use those UI controls flexibly, and you can then make your tests a little bit more maintainable. But I do think that they have a ton of value with being able to run your tests automatically really quickly and without having to have, manual tester intervention every time you want to run that test.
And I'm going to throw in a couple of benefits as well. For a team-based development environment, we're making our way up, right? We're getting to the very pinnacle here of our testing triangle. And in that testing triangle, fewer coded UI tests are probably good, but the key to having them is to have good ones that can be repeatedly run. Now, first rule of coded UI, don't automate tests while development is in the rapid churn cycle. So what happens is, as developers are developing things, they're going through and changing the UI, getting feedback from customers, making radical changes very, very rapidly. Just don't hurt yourself by doing it then. That's the time for manual tests, executed repeatedly by a person or the tester for a good period of time. But pretty soon, the UI starts to stabilize. The UI starts to get very, very clean. And at that point, that's when you want to start automating those particular pieces of the UI. So that's my recommendation on those automated pieces. I mean, if you have a lot, if you're going to have hundreds to thousands of these automated tests, I want to make sure that you also consider building out a testing framework that has like a hierarchy of tests and an inheritance hierarchy where your UI map and stuff is not just generated at each and every time you do a recording. You create some UI maps, or you create things that are going to be reused throughout the development environment. Let's take a look at some of the power that we get when we start bringing in automated and coded UI tests to our application. First,
I know you want to talk
I
about
know I want to touch. Should I let you talk it?
No, you can.
Okay, speed time to feedback. Again, boom, boom, boom on the drum. I want to have fast feedback. Every time I commit my code, I want to know if it built. Every time I run it, I want to see if a piece of unit test failed. Every time I push this out to my dev environment, I want the automated UI to come back and say, no, you did something wrong, go back and fix. I want that constant cycle. I crave the feedback that you get in a good, agile, or a lean delivery team. And the coded UI gives me some of that. And here's the thing I cannot stress enough. When you have coded UIs, you get that fast feedback, but not only that, it lets you shorten your delivery cycle because you can now all of a sudden spend less time in regression and more of your time building things, testing the dangerous parts of your code, and getting to production faster. The more you go to production, the faster you can get to production, the less code you're shipping to production. You do it incrementally, which means less risk. Coded UI, all of these feedback mechanisms mean less risk when you go to production because you're able to deliver faster chunks of value. So that time to feedback, precious, absolutely precious.
And you can also find regression errors with automated UI tests by, making sure that you haven't messed up an UI control or a button or a search field or anything like that. It makes it just like manual tests, it makes it really easy for you to be able to find regression errors and bugs and be able to file them. And the cool part is, let's say that you file a bug that's a regression, regression bug, and then you associate that with your test case, and then you associate the coded UI test with your test case, then you have them all connected together for regression.
And funny, you should mention that because I've seen places that have then gone ahead and hooked them together. So if the bug goes into the resolved state, that one is specifically executed automatically, and if it passes, the bug is moved to closed.
That's awesome.
Yeah, it's your call if you want to do the switch in an automated fashion, but you can do some pretty powerful things. The next two I'm going to hit real quickly. They're save tester effort and time. This is just the key of automation, right? If you get automation, it means that the testers don't have to be manually clicking. Anytime you take really smart people, technical people, like good testers, and you put them in front of something highly repetitive, you're calling for errors to be made. Highly repetitive things with very intelligent people results in very oftentimes some problematic things. Let's leverage your testers where they're strongest. Next is validate your business logic. Once again, we're going to be walking through this just like those acceptance tests that we built earlier manually. We're going to be doing the same thing here. And Sachi, I promised this one to you.
And then the last one is that you can really improve those automated deployments when you have these automated coded UI tests, so that when you deploy, then you can run that coded UI test on that machine that you just deployed, and then make sure that everything looks good. So I think that testing is really important to the build and deployment pipeline. So it's just really an integral part of that.
Let's talk about Selenium. Selenium is an open source tool that allows us to drive most modern browsers. We can drive browsers like Edge, Firefox, Chrome, any modern browser basically. And it allows us to automate the creation through either an IDE recording, where we can record our steps and it creates a script for us, or directly through scripting. What's nice about Selenium and why it's become so incredibly popular is that you can script it using a number of languages. You can use Python, Ruby, Java, C#, F#, you name it, JavaScript. You can record your tests in the language that's most comfortable for you. And you can use the same script to drive a number of different browsers. It's a very powerful framework that's become very, very popular. And another thing that's nice is that you can integrate it into your continuous delivery pipeline. So if you're using Visual Studio Team Services to automate your build and releases, for example, you can plug in Selenium and run those tests just after deployment to make sure that your build and deployment succeeded.